Hello guys, welcome to our last week from Model 4, and this week we are going to replicate the exact same result you are watching on the screen. We'll import the ship, prepare the geometries, we'll also add the water and the foam passes, and we'll see a bit of render and lighting. We'll also add some extra forces in order to work our simulation on a more controllable way. So let's get started. I will save the scene onto my path. I'll create a new folder, Model 4, week 8. And inside I will save the scene as Model 4 with 8 sailboat version 1. Okay, the first thing I'm going to do is to import my boat, my ship. I'll name this as ship, and inside I'll grab a file node, and right here I'll pick up the geometry that I've found on the internet. It's sailboat.obj. Okay, we see the scale is pretty big, so I will add a transform node. I'll just translate on y to negative 0.75, and also the uniform scale is pretty big, so I also reduce it. Okay, so yeah, more or less we have a 50-meter ship right now. So this guy right here is the model is not working good, as it will touch the water, but don't worry, you will use another model and nothing of this should happen. But what I've noticed on the ship is that the area that collides, that is under the water, it's divided into two. So we need to prepare all this geometry. We need to weld those vertex and generate only one mesh from here. So I will keep this lower part first. Let me select. Let me delete, and last node is here, delete non-selected, and I want to keep this guy and also the upper guy. Okay, let me unparent and delete non-selected. Let's merge these. Okay, now we have our two geometries, and first of all let's convert this, and let me add a fuse. The fuse is a node that will allow to merge two geometries into one based on the position of the vertex. It will weld them. So now we can see that we already have one single geometry. You can play with distance, but right now the default values are working good, so let's keep it as it is. But this guy needs to be a close geometry, so we don't need any holes. So let me add a polyfill, so we don't have holes in the geometry. Let's try afterwards with our collider when it converts into BTBs to see if it's working. But okay, here I have a warning, not big deal. Let's see if later on this works properly. So as a node, I need to create a a follow, because the animation of this boat should follow the flip tank that we are going to create. So it's better to get connected this out follow. I will show you in a while how this is done, but as soon as the ship travels into the water, this container will follow, and this will earn a lot of RAM memory and get a nice result, you'll see. So next thing I'm going to do is to create a flip tank, but it's the initial. So let's dive inside, and I'm going to create an object merge. Two object merge actually. The first one is a follow, and I'm going to pick up our out follow, and the second one, this guy goes right here, so let me pick it up again. It's okay, there's the out follow, and the second object merge, it's going to be for collisions purpose, both of them into this object, and I'm going to merge these two objects. So after this, I'm going to create our ocean wave tank. It's called our ocean source, the node we are going to use. So okay, let's turn on oversampling. You already know this. Let me check for the attributes. We are going to connect later on the rest of the attributes, so let's continue by creating another node. That this will be the out. For our initial, and then remember you need to split particles to separate particles and surface. So let me create two nulls. The first one is out particles. Now let's name it initial particles. And the second one, it's our out initial surface. Now let me add a blast node, and inside our group we need to filter our particles and delete non-selected. Okay, there we have our particles, so this is fine. Let's name things just a bit properly. And I want to duplicate, and now I need to surface, to blast the surface. So let's add name equals surface and delete non-selected, so we keep the surface. That will be useful later on when we connect our DOP network. So I think that's it for now. Let me create a DOP network. And name this Ocean Sim. And as you already know, inside we need to create our flip object and solver. First the solver, and then the object. First input connected, and I want to set the initial type to narrowband, and I'm going to pick up both of our out nodes, particles and surface. the particle separation should be connected, so let's copy this parameter and paste a relative reference on particle separation so it updates. And we'll also need to plug this out, change the visualization. Particles, and I think that should be it. Let's check the size of our tank because it's too small right now. I think that 40 should work good, 11 and 100, 104. And for the center we need to copy the centroid information of our follow, so let's type centroid brackets, and I'm going to grab my merge follow node, the one on top. Let's open brackets, okay, comma, and let's get d underscore x for x-axis, and I'm going to copy this and paste it on z-axis too, and that way the box should follow the rest of the simulation. Okay, so nothing else to change here. Let's probably update this value so we don't have so much depth on our ocean, and that should be good. Particle separation also is not working that bad. Also inside particles, let me check the layer size. Okay, we don't need so many particles underneath, so that should be it, I guess. Okay, let's go into the ship and add some animation, because we need this to move in order to see that the follow is working. Also, let's increase the particle separation in order to have less particles. And okay, everything's moving together, so that's exactly what we wanted. So I will add an expression in order to transform the ship, but first of all I want to place the container better, because I want the box to start very near the front part of our ship. So let's add 20 units to our expression, and now the center, you see that the simulation will start as soon as the ship, the front ship, animates and generates some nice waves. Also the initialize method, let's update to flat tank, and I want to turn on fill volume and narrow particles. I also want to reduce the layer size to 0.75. The type, the evaluation type is flat, it's okay. Let's increase the scatter density and oversample bandwidth also. And you have a bounding layer. This is the offset and the connection between the ocean, the rest of the ocean that we will add later, and the simulation patch. So this layer can be increased or reduced in order to have a smoother transition. For example, 1.5, but just to show you, I will keep on 0.75. But you see how you have a larger offset now. Let's leave that as it was. Now let's check and add our collision geometry. Let's go to the ship. Let's connect it to the polyfill, and under collision static object, let's select the object and hit enter. Okay, now we have our source, collision source. Let's see if the BDB is working properly. Although we have a warning, it's okay. So I want to reduce this voxel size to 0.25. Yeah, we don't want to waste many times cooking this, so let's leave it right there. Let's lay out with L key the dot network, and under ship everything should be working fine now. So let's use deforming geometry, so we keep the animation for our object, don't forget that. And also let's check collisions to see if our guides are working. Perfect. So that's it. We can try a preview. Let me name this as animation so we have things clear. And let me add also the animation expression. Translate, let's add a $T multiplied by 1.75. And I want to offset this 4 frames, so -4 units. Okay, so let's keep our dot network and let's first save and make a preview and see what we get. Okay, here's the result. With the follow is not working, but collisions are doing. There are some wakes, obviously gravity is missing, so the first thing we are going to do is to add this field. And the follow is not working, that's because under we need to connect size and center attribute. That's happening. Okay, this is inside the solver. So in volume motion I need to connect these guys into the flip tank initial. So sorry, not that one. Let's roll back to parameters, and I want to paste a relative reference right there, so let me grab it from the flip tank, copy size, copy parameter, and paste relative reference. The same for the center. Paste relative reference. Okay, now the ship and the container should move together. Also, we need to connect the boundary layer. That's why we created it. We can connect it or just type it by hand. And also, I want to turn on the use waterline option, that and also turn on the fill new volume. Okay, this way. Let's play back, and we now see that the fluid container is following our animation. Just one thing was missing. It's the closed boundaries. Keep it on all except on y-axis if you want, otherwise it should be working pretty fine, because we won't have any collisions on the top part of our container. So this is what we are getting. There are still missing some things to connect, but I won't spend much time on this. Let's create this from the shelf tool in order to compare how fast and simple things are. Sometimes it will earn a lot of time that you can spend adding nodes or developing or adding some extra forces. We see everything. We have collisions, we have movement, but we have deformations on the back part. But well, I would like to add some custom velocities in order to control also emission and deformation from these guys. But first of all, I think that I'm going to grab a new setup from the shelf tool, because we are missing some stuff to connect, and this will take too long. There are many things. So let's delete this, and I'll show you how in 2 minutes we'll recreate all this stuff that took us almost 20 minutes. So let's go into Oceans tab, and let's create a flat tank. We have a flat and an ocean tank. You can try both of them, but for now I'll use the flat tank with my ship selected. Okay, and everything is already connected. We have our outfollow, the same thing that we have previously. We only have to adjust the size. Let's lay out this and put the nodes, place them on a better and more legible way. Let's type back our values. Okay, Y size, it was 11, and the center was 3.4, the same attributes that we already had. The center, I need to add 20 units. Sorry, not multiply, add plus 20. Okay. And the size is probably a bit too large. It's not fitting the version we previously have. Also boundary layers are already on. Okay, the size is 105. I was missing that guy. I want to lay out this again. There's already a narrow band connected, particle separations. Let me reduce this. And we already have a collision, but I don't want this. I prefer to generate this from volume. So I'll set up collisions again. Just it probably works in the same way, but I'm used to work with this BDB workflow. So let me grab the ship, and inside the flip tank now we have two static objects input. So let's delete the old one and keep the new volume one. Okay, so we have some deformations happening there. Let's save this and let's make a preview. First of all, I want to add the forces. I will add some extra forces to push the water even more and to control on a better way. Let's start by creating a grid. This grid will be placed on the front part of our ship in order to create a better wake, some more controllable ones. You can also add it in the middle and the back part. I'll show you the workflow for this. So let me adjust the size of this grid, and let's name this, no, let's connect a point because I want to add normals. this should be a constant value, and I want on X axis. So let me show you normals. Sorry, normals, not velocity. And we have on the x-axis normals going up. So after this I want to create a bend in order to give some nice curvature. Let me grab it. Hold on, that the node didn't appear. Yeah, okay, it's bent. I was looking at blend, so it's bent, and you need for this bend to set up to 90 degrees. Let's visualize this. And I want the capture originate direction to update. Let's add a -5 on X capture origin, and 1 the X direction, 1.8, and also let's increase the length a bit. Let me check if attributes is okay, because we'll need to keep normals. Also change the direction on seat to 0, so now we have a nice, it's a kind of ramp of, and now we have normals. So recompute affected normals, turn it off, because I wanted to keep the old ones. Okay, now once we have this, I want to transform and place it, also scale it a bit down, and placed it on the front part of our ship, just where the initial collision occurs. Let's grab a top view and place this. This should be done manually and placed also correctly, otherwise the wakes will happen another place or won't work that good. Let's fix this, and we are almost done. Probably move it a bit. Okay, it's very fine tuning what I'm doing. But this way you can also control, will match the movement of our water. So basically by controlling the scale and position you'll get different results. Let me duplicate this, and I want to place it on the other part of our ship. And I want to merge these both together. It's probably need to be, that's better. Yeah, I think that this will work much better. Okay. That's it. They're placed perfectly now. And I want to convert this into points, so let's add a scatter. So we have a better distribution of our points and our velocity, sorry. Let's turn off randomized point order and also the relaxed iterations. And the same for the guy on the right. We'll also increase the particle count a bit. 3000 is okay. And I want to add a point wrangler and set that velocity is equals to normal. And let's add a multiplier in case later on we want to increase or reduce speed, but we can also make it from the dot network. Finally, I want to add a null and name this as out front velocity. And now we have our custom force ready to be connected. So we have a velocity there, so it's fine. Let me visualize. Everything's working pretty nice. So right underneath our mesh, I want to add a force field. Field force and our sub geo. And let me grab the velocity that we just created. So use transform object and set default operation to always. And the force on our force field is velocity. Now we see the guides, so we are on the right spot. Let's reduce the vectors a bit, and our velocity, let's try a 2.5 and see what we are getting there. The torque is okay, and the max distance, let's reduce it to 0.15. And also remember to set to always, otherwise it won't update frame by frame. I want to turn on particles there and don't need display our guides, but I still see some particles. Let me check. Let me turn off custom velocity. Well, I guess that Houdini crashed, so let me save this and open it again in order to turn off those particles that we really don't want to be there. Okay, so here we have our ship. Let's play back this and see if the forces are really giving us a better result. Let me reduce particles a bit so we get a faster playback. Not 0.5 but 0.35. Okay, and let's make a preview. Okay, this is the result that we are getting. It's working pretty nice. Our force is probably too high or too intense. We can play that, but the deformation we are getting over the water is acceptable. It's working good. So let me fix the position of these custom fields. Let's turn off the ship, and yeah, they are probably they should be in the level of our water. So let me add a transform after this merge node. And I want to place them negative y axis. That should be fine. Now it shouldn't go so high. You can also rotate these planes in order to get different results. Okay, let's play back this. We can also add a force, the same workflow we did for the front part. We can do it for the back part. But yeah, this is working much better. The collision plus the custom velocities are doing a great result. So let's add the back part of our ship I want to object merge because I'll use the ship geometry to emit velocity, and I think the outfollow will be very useful for us. And I want to isolate the area where the ship is in contact with the water. We will add just like a engine pump of water. Let's select that, non-selected, and the workflow is pretty the same. I want to add some point. Let's set the normals to a constant value. And -10. It's +10, okay. And now I want to scatter points in order to have more areas of velocities points. Okay, I think that I should select those polygons, not the one over the water. I guess that it will give a better result because engines are on the bottom of the water. So I want to just keep those guys. Okay, while hitting delete everything messed up, so let me fix this. So first the object merge, then the blast node. Let's put it into non-selecting mode. Then the points, and I don't want this merge at all. And again I want to scatter and increase the particle count a bit, the point count. Okay, and now I'll grab, let's delete this guy, and I want to grab the last part of the other setup and name the outfield as out back bell. Okay, same thing here. I just want to duplicate and replace. Back bell or velocity, and also okay, let's put the camera just a bit and play back this to see if it's really working, or it needs more intensity on the back part. So let me increase, and also the max distance. Okay, let's make a preview, but we see how particles are being pushed back. It's probably too high, that velocity, but we have control over this. So let's reduce this guy just a bit. So result should be much better and subtle now. Let's play back this, and let me pause this. But I think this is okay. We are getting a nice back emission on our ship. Although this is not an engine boat, well, you can control everything here. That's the nice part about this setup, but I'm pretty happy with the results we are having. So let's make a cache of this. and let's start working the white water. So let me reduce this. I want to save our scene and increase our resolution 0.075 is the final resolution I've used for the preview that I show you. It's 7 millions and a half particles, so that's pretty enough and nice to get a result on our water deformation. So let's get into a flip. Everything was created from the shelf tool. Let me set a path and I'll cache this out. Okay, this is the result we are getting. It took a while. Just be patient and we can see a nice deformation. This is exactly what we are looking for. The only thing from here is that you will need at least 100 frames for pre-roll, so we have a larger wake on the back part of our ship. So let me go to frame 183 and yeah, that's it. Let's see a bit our meshing and it's taking a while, sorry. Let's create the white water right now. So let's do this also from shelf. It's the same workflow we used the previous week, so don't worry about that, you already know how to do this. Otherwise just go back to the previous week and double check. Basically, hold on, that this is not working. Just by selecting the white water object, the flip object, and hit enter, that should give us okay, now it's there. No, sorry. The problem is that I getting this error, not sure what's going on. Hold on. White water. And hit our fleet tank. This is the guy that we need. Hit enter. And okay, there we have our white water. Not sure what was going on, but let's reposition our nodes to get a clear view. Okay, source, sim, and import. Inside our source, remember it's going to pick from the cache, and let me visualize the white water source. Let's hide everything. We don't have anything there because we are on the first frame, and the first frame we don't have any deformation of our water, so we need to start at least on frame 48 or 50 where we already have some water deformation. Okay, there we are. So now we should have a better and clear view of our white water source, this kind of nice volume emission. Okay, it's pretty transparent now. I want to change the display, set it up to dark. Okay, it's probably too light, but right now, as you already know, we have to play with these values in order to have a better and more intense emission. But this by default shouldn't work that bad. Let's start by seeing the different results we have with max and min curvature. The more curvature we have, this kind of threshold, so we have more emission just on the front part where we added the custom velocities. Emit from acceleration, and also you can play around with this. So we have a more intense emission happening there. I like that. Vorticity, let's keep this as it is for now. I want inside the visualization to see which field is each of these guys. Voxel size is okay, it's 0.15. Okay, we have a lot of acceleration, not much curvature, and almost nothing on vorticity. So we can play around with acceleration a bit, and also the curvature. So as I told you, the more information you have, the more particle emission you'll get later on. This is all a balance, so the more information you have, for example here in the curvature, just see how now we have a nice emission where the fields that we added are. So yes, I think this might work nice. You can cache this out or just move into our source in order to get our particles amount inside whitewater object. Let's leave it as it is. We need to play around with the solver a bit, but first of all let me hold on. I would like to add the collider also, because I want collisions on the white water from our ship. So let's merge this, and the white water scale I'll reduce it, so because we want more particles in there. And this is all playing around and making test. You have to find a balance between RAM memory and nice detail. Right here I'm working with a 128 gigas of RAM, but I guess you'll need to tune this down for 64 or 32 gigs RAM. So I think this is fine. I would like to reduce the emission amount, and inside limits it's okay, inside force is okay. In foam I don't want to use those repellents. I really don't like the result they gave me. I made several tests and I prefer to turn them off, and this by default should give a nice result, and that's it. So from here there's nothing else to play around, just the particle, the white water scale and voxel size are the two most important guys. So let's make a cache of this current setup and see what we get. Everything is already built up, so you don't have to worry about this either, but we'll play around with these attributes later on. Let me cache this and I'll be back as soon as this is done. Okay, I cache it from frame 100 to 200 because I didn't want I wanted to calculate but not to save it to disk because it was completely useless. It's the pre-roll stuff, so we didn't need to get those files on drive. So 129, and we have some nice foam particles on our shot, almost 20 million particles. Should give a nice result. You can obviously go up, it depends, as I told you, on the RAM memory you have on your PC. So the next thing I'm going to do is to see this with our water geometry. So let me inside our flat tank. I'll grab some lights first. I had it already from other scene that I made, so it's just an HDR and point line. You already know how to do this. And let's go to our particle fluid. It will take a while to cook. Let's give some time. I'll pause this if it's taking too long, so don't worry. But it's almost there. Okay, and this is our result. I'll increase the droplet scale because I guess it's too noisy, and also I want to turn down adaptivity because I want to add some nice deformation over that. You'll see in a while. So let me set the display flag on our particle fluid source. And here we are. So we have our water deformation. It's probably too noisy, but it's not working that bad. Let me go to the filtering and add a smooth operation, and I will increase it. Yeah, the main problem is that we probably have to reduce the resolution or increase the number of particles on our cache. That's why we are getting those noise. But let's say a 15 on our smooth operation should reduce that a bit. Later on, when we add the water deformation over this, you won't even notice. So okay, particles and water is happening here. Let me turn on our ship, but the complete model for rendering. This transform guy should be enough. Let me place a camera. So we see better our result. Yeah, that's a nicer view. And inside render view, let's grab our camera and render. Okay, this is the first results we are getting without playing with shader, and it's almost, we cannot see the white water. So let me turn on the fleet tank and see what's going on. Particles are there. Inside the attribute wrangler, nothing to change here, to be honest. And I probably reduce the particle scale just a bit. The voxel size is okay. Let's reduce so it doesn't take so much time to calculate, but the detail won't be almost noticeable if I use a 0.085, for example. 0.009, okay. And also let's reduce the particle scale just a bit, 0.75. And the most important thing that I need to update is the shader from this guy, because I need to increase the density. So let's go to material, to our white water, and yeah, definitely density scale is too low. Let's turn it to 60. Let's snap this and see the difference. Okay, now we have more density and a better view of our foam. So yeah, this is fine. Let me go back and turn on our flat tank and see all together. Okay, render is pretty fast. And yeah, now we see we are getting some nice foam happening there. We can probably increase a bit the intensity of our color, so they are even whiter. So let me also, I'll increase the particle scale, so we have even more volume on our foam. Okay, this is the result we are getting. We have nice foam, and in the shop, no, not shop, the material, let me increase the color value, so we get whiter areas on our foam and not that gray. Okay, that's much better. Well, as I told you, what I'm doing next, I'll save this and I'll add some deformation, some water deformation, to avoid seeing that noise on the ocean surface. So I will do this with an ocean evaluate, and the same we did in the previous weeks, but just after this fluid source. Let's add an evaluate and a spectrum. Okay, let's plug this, put this together. You already know how this works. So let me increase the resolution exponent to 11, depth gravity, well, that's not that bad. Let's reduce the scale a bit, and I want to visualize this on the viewport. Okay, nice water there. Yes, this is exactly what we wanted. So what I'm going to do is to take this also to the particles, because they should also have the same deformation. Otherwise the result on animation will be pretty strange. So let's add an ocean evaluate, let's plug it there, and I bring the spectrum with an object merge. So when I update one, the particles should be auto update too. And let's grab our spectrum. So now, if everything's good, we should see, some deformation happening there. Okay, let's make a render test. Let's save this first. Save as an app to compare, and let's see what we get. Okay, so the result is way better. There's no point of comparison. I really like what we finally got here. But I guess, later on you can add an extension from this ocean, adding the same spectrum to a grid with nice resolution. So well guys, this is it for now. Hope you like the training and this week, and thanks for watching.